Alright, so just now we have seen band reject filter, right, and let us see how we can use this band reject filter by in an experiment. So, to quickly recall what is band reject filter? Band reject filter is the filter that we can design to reject the band of frequency. It is kind of opposite to band pass filter, right. In band pass filter we are passing the band of frequencies of desired frequencies, but when we talk about band reject filter, then we are designing a filter that will reject the band of frequencies. So, the point is how we can design this band reject filter. So, in the lecture right now what I have taught you is how we can, what is band reject filter, what are the kind of band reject filter, how you can design the band reject filter, and now you know that we are using the low pass filter and high pass filter, but not in terms of cascading. Like if you see band pass, it was high pass, then you have low pass at the end, and you have the op amp in the center, right. It can be buffer, it can be inverting, it can be non inverting amplifier. In case of the band reject filter, we are applying signal to low pass and high pass both, right, and then we are connecting it to the inverting amplifier or non inverting amplifier, followed by a summer. Actually we are not using inverting amplifier, non inverting amplifier, or we can use the point is low pass, high pass goes to buffer, buffer to a summing amplifier, right. That is what we have already seen. Now, let us see using our favorite equipment, that is the DC power supply, linear regulated power supply, function generator and the oscilloscope, how we can design this band reject filter, and we will see active band reject filter. What is active band reject filter? Where you are using the operational amplifier. So, now this is a breadboard that you can see in front of you, right, and today I will introduce you to my third teaching assistant Anil Vishnu, and he will help us to understand how we can design this particular circuit. So, Anil is here to help us, and he will be showing us how the circuit you can implement on the breadboard, and while he is implementing I will keep talking so that you understand what exactly he is showing. Okay. So, if you quickly go to the screen for a second, you will see that the experiment is to study the working of active band reject filter. Active band reject filter. So, now what we see, you can see the circuit which is shown here, right, and the signal that we are applying is to the low pass and high pass filter, you can see here, correct. This output of the low pass and high pass filter is connected to the buffer, to the voltage follower or to the buffer, as you see here, and the output of this is fed to the summing amplifier. This is your summing amplifier, easy. So, let us see what is that, what I have said, buffer or voltage follower, right. This is a combination of low pass and high pass filter, This one is from here, if I see, this one is your summer, or summing amplifier, right. So, when if we want to implement this circuit, what is the first step? You have to connect the circuit as shown in figure, this is figure 19a, right, and the we have also performed a simulation that I will talk in a second. Let us first see what the circuit is. The circuit, once we connect as shown in figure 19a, right, we have value of R1, R2, C1 and C2, right. R1 is 10 kilo ohm, R2 is 1 kilo ohm, C1 and C2 are 0.1 microfarad. The cutoff frequency here when we calculate, it is 159.15 hertz for low pass filter and 1.59 kilohertz for high pass filter. Now, what we will do? We will apply a 5 volts peak to peak sine wave here. We will apply 5 volts peak to peak sine wave, right, peak to peak sine wave of 50 hertz, right, at V1, and slowly increase the frequency at a step of around 20 hertz. Slowly we increase the frequency from 50 hertz, we will go to 70 hertz, we will go to 90 hertz, we go to 110 hertz and so on, so on and so forth. Now, after this what we have to see? We have to see the output, at the summing amplifier, the output of summing amplifier. The combination of all this is your band reject, right. You have op amps, so it is active band reject filter, right. Now, apply a 5 volts sine wave, we have applied 5 volts sine wave, we will apply say 5 volts sine wave and then we will slowly increase the frequency. Then we observe the output at VO, this is output at VO which I have shown with arrow, this one. And what we will be observing? We will observe that a frequency which is equals to cutoff frequencies, the amplitude is A by root 2 and above and below the cutoff frequencies the amplitude is attenuated. What does that mean? That whatever cutoff frequencies is there, right, you have two cutoff frequency, one is cutoff frequency FL, second is FH, one is FL, one is FH, right. The frequencies less than FL and frequencies greater than FH would be allowed to pass, the frequencies between this will be attenuated, right. So, if you see this particular graph, this we have the results obtained using this NI multisim, and what we see here? There is a amplitude versus frequency. Here there is a phase also, phase is also there, right. So, one axis is amplitude, another axis is phase. This is the amplitude plot, the one that I am drawing here, right. I am just following the amplitude plot and this is the phase plot. This is the phase plot, right. This is the amplitude plot, this is the phase plot. So, let us see how our output voltage VO, right, changes when we apply input voltage 5 volts peak to peak from our function generator, So, when we talk about function generator, right, for our function generator, the voltage that we are generating from the function generator we will apply at this particular terminal V1, alright. So, we have to see how the circuit looks like and then we will see how it works. Okay. So, if we come back to the breadboard, we will see the function first the band reject filter which is right over here, and you can see that there are 3 op amps, right, just hold on, you will see in a second, yeah, that is fine, do not worry about it. So, now we have here 3 operation amplifier 1, 2 and 3, right, because in our circuit also we had 3 op amps, right. One is summer which is this one, and then there is a buffer, and then input is low pass and high pass, and to the input we are applying 5 volts peak to peak signal, alright. So, from where we will apply? From the function generator. So, if you can see the function generator, we will see that, can you keep it back, let him focus on function generator, the it is 5 volt and now he is changing the frequency is 50 hertz. Right, 50 hertz frequency, 5 volts peak to peak, he is going to apply to the input of the breadboard. So, let us apply it. Let us apply it. The signal goes to the input and another terminal goes to the ground, and we have applied plus minus 15, we have to apply plus minus 15, that is the biasing voltage, to the operation amplifier. Alright. Now, we have to connect the oscilloscope, that is the output voltage of the circuit, to the oscilloscope. We will also connect the input and we will also connect the output. So, we can compare the input and output both. So, we are connecting the input and we will also connect the output. It fell down. So, you can see clearly on oscilloscope the input signal. Now, we are connecting the output, right. So, one terminal is ground, one terminal is connected to the VO. One connected terminal is connected to the VO. Now, at this point we should be able to see some voltage. So, let us see whether we can find some voltage at the output or not. Okay. So, what we find is there is some problem with our circuit. So, let us troubleshoot the problem. And find out where the problem lies, and once we find out we will get back and continue this video, because I just do not want you guys to sit in front of the system and wait until we troubleshoot the problem. But the point is, now in this case you can see that we have applied the input. Since you have 3 operation amplifiers, you have 3 op amps, right. Why? Because you are using the buffer, you are using the summing amplifier, right. So, you have 3 operation amplifier. So, 3 operation amplifier we have 6 resistors, we have 2 capacitors, we have bias voltages, we have input signals, we have output signals. So, circuit becomes little bit more complex. When this kind of circuit is there, it will be difficult for us to get the result in one go, and it may be the condition which we are finding right now, which we are in right now, right. So, the point is, how can we find the solution to it, or whether we can troubleshoot the circuit or not. That is the point that we need to understand. We will find it out and we will continue the video. Like where we stopped, we will start from the same point, and the point was on the band reject filter. So, when you talk about band reject filter, right, we were looking at the circuit and we were not able to see the signal in the oscilloscope, right. So, point was why we were not able to see, so we have identified the mistake in the circuit design, and what we found is one of the terminal was not properly grounded. Alright, one of the terminal of the summing amplifier was not properly grounded. Just because of this small error, which is not really small, you cannot find the output which you are looking for, So, but the point is, you should be able to rectify your mistake, you should be able to find out where exactly the fault is, right. So, that is what we have found, and now if you see that when we apply a voltage at the input, right, apply the voltage at the input which is 5 volts peak to peak at 50 hertz, then what is the output. So, if you see the function generator, you can see 5 volts that we have applied, and the frequency is 50 hertz. So, he is adjusting it to 50 hertz. okay, 5 volts 50 hertz we have applied, right. And now we will look at the oscilloscope, that is output of the band reject filter, output of the band reject filter. Now you see the cutoff frequencies are FL is 159.15 hertz and the higher frequency FH is 1.59 kilohertz. So anything below FL will pass, anything above FH will pass, the frequencies between FL and FH will not pass, that is the role of your band reject filter. So we will keep on increasing the frequency. You can see here yellow is your input signal, blue is your output signal, peak to peak voltage is 5.2 volts, and you see that slowly when we increase the frequency, now you see 139 hertz, stop it here, 150 hertz, and when for 150 hertz what is output voltage? Output voltage, so the peak to peak voltage, yeah, 5.12, and you can suddenly see that now the amplitude will start decreasing, right. Okay. Yeah. So, frequency is 159.002 hertz, okay. And if you increase the frequency, suddenly you will see the drop in the amplitude, suddenly you see the peak to peak amplitude is getting decreased. You see blue one on the left corner, can you point it out, 3.1 2.696, yeah, 2.96 volts. You see the amplitude is decreasing. Why now? Because it is within the band of 159.9 hertz and 1.5 kilohertz. So it will completely attenuate, it will start attenuating. You increase the frequency, keep on increasing frequency. Can you auto adjust here, oscilloscope please? Okay. Now keep on increasing the frequency please. Yeah, you can just see the oscilloscope and you can see that we are still increasing the frequency. You can show the where you have reached the frequency please, 1.75 kilohertz. Now if I keep on increasing the voltage frequency above this FH, then I will again see the increase in the amplitude. That means again my signal is allowed to pass through the filter. What you have seen again, you see the peak to peak voltage, it is back to 4.56, 4.8, which is close to our input signal, right. So what we see is when we have signals which are below FL, we can pass, when the signals are above FH we can pass, the signals between FL and FH we cannot pass, and that is what we have seen right now. Now we will do the reverse of this. Now we will decrease this frequency, we will decrease the frequency and look at the signal. So can you please show the oscilloscope once again? Yeah. So you see on the oscilloscope, just hold on, show where the frequency they have to see the frequency is right over there, and you have to see the peak to peak voltage at the output, which is this one. So two things you have to remember, frequency, when I talk you have to see frequency and the peak to peak voltage. The yellow one is your input signal, blue one is your output, okay. Now we are decreasing the frequency, and you see that when we decrease the frequency, you concentrate on your peak to peak voltage, alright, decrease it further, and you see now suddenly you can see that the voltage is also started decreasing. Now we go down all the way to 159 hertz, can you please auto adjust? See, there is a function called auto adjust and it will automatically adjust your waveform, right. If you do not need to adjust it manually, it can automatically adjust. Now you see here below 151 hertz, below 159 hertz, it will again start increasing. You see the voltage again started increasing, right, That means that the peak to peak voltage will decrease or will attenuate only between 159 and 1.59 kilohertz. Now if you come back to the screen, so let us assume that this is 159 and this is 1.59 kilohertz, okay. This is 159 hertz and this is 1.59 kilohertz. Now you see the signal. So, voltage starts attenuating way from here actually, right, and then it comes down here. So, that is why you will see that even you come to 115, 118, you can still see that voltage is decreasing, it is not 5 volts anymore, it is 4.8, it is 4.5. So, this is the peak that you are looking at, this is the amplitude that you are looking at. Same way when you increase it, it is still even it is outside this, it is greater than 1.59, you can still see voltage which is less than your original voltage or input signal, which is 5 volts. That is why you cannot see suddenly there is a change in 5 volts, sudden change will be there only when your filter is ideal, your filter is ideal. That means what, that you have this instead of this kind of curve, what kind of curve you should have, suppose this is the frequency FL, this is the frequency FH, your curve should be like this. Right. If you have only one frequency, then goes like this, right, but we do not have ideal filter, and that is why the change in the voltage that you see with increase or decrease in the frequency is not exactly like this, but it is similar to what we have shown in the slide. Alright. So, do not get confused and do not say that oh it is not working, it is working, this is the area that you are looking at, this is the area you are looking at, and after certain frequency you will be able to see 5 volts again, you will be able to see 5 volts again. Alright. So, guys, now you know what are the band reject filters, now you know what are band pass filters, and now you know what are high pass filters, now you know what are low pass filters, now you know what are active filters, now you know what are passive filters. So, we have seen all the kind of filters, possible filters that I can show it to you quickly in the part of as a part of this particular curriculum or part of this particular course, and we have seen the filters right from low pass to high pass to band pass to band reject, right, with experiments, alright. So, I will see you in the next module and we will see other applications of the operational amplifier. Till then you take care, learn the filters, understand the importance of filters, understand where you can use the filters, what are the real application of the filters, right, and try to see in which kind of electronic circuits the filters are used, right. So, the point was that at the starting of this particular filters lecture, I told you that the filters are generally used or most widely used in the communication circuits, in the communication systems, alright. Okay. So, I will see you in the next module, till then take care, bye.